So if we will want to figure out how to schedule these operations, we need to think about how the state is evolving with time as it experiences idle noise, and also as we interject our QEC operations. So I'm going to mostly describe this using the visuals on the right, but the equations to the left are showing the corresponding mathematical representation for what we're talking about. So starting from the top, initially, so the blue bar represents how much of our state is in the desired component, the target component, because our states can be decomposed into desired, correctable, and uncorrectable components. These are orthogonal or independent of each other. So initially, we start with a really high component of being in our target state. As time progresses, during our idle waits, the probability distribution sort of diffuses more toward our correctable and uncorrectable components. So one way you can visualize what happens with our QEC circuit is the amount of you can say probability sitting here in the correctable subspace can still be recovered. So as we apply our QEC circuit, all of this this weight here we have in the correctable subspace gets pulled back into the desired subspace bin shown here. And so this is how we get a boost. If we wait a very long time, then we get a lot of uncorrectability that we just can't recover, because our QEC circuit has a very limited capacity to correct only a certain number of errors. So this is how we get a boost as we apply QEC. So here, again, we're showing the boost where we've taken from the correctable part. But we do also have to account for the fact that our QEC circuit does incur some impact, a little bit of noise itself. So there will be a little bit of a drop here in our post QEC fidelity due to the fact that our circuit itself has gate noise. And so we model this in a conservative way. This is a fairly complex problem. We model this conservatively with essentially a constant offset that can be tailored also toward how long you are into the schedule when you're applying your QEC circuit.